So hello everybody and welcome to today's presentation for Realize Live, hosted by Maya Heat Transfer Technologies here and IVI. Today's topic of discussion will be about IVI and how they're using Simcenter and MBD to support their engineering tasks around vehicle electrification and mobility, and ultimately to help deliver a better result more efficiently. The agenda will be as follows. We'll have a brief introduction to IVI, hearing about their history and their mission statement. Then we'll discuss the background of collaboration between IVI and Maya HTT. Then we'll take a closer look at how IVI is using engineering tools to help accomplish their goals, particularly the ones provided by Simcenter and Siemens. Finally, we'll dive deeper into one of IVI's recent endeavors and explore the use of engineering tools in that context. First, let's introduce today's speakers. My name is Anthony Lorella. I'm a technical pre-sales consultant at Maya HTT, specializing in system simulation and MBSE tools. I'm joined today by Pierre-Luc Lapointe, the mechanical team manager at IVI, who will be sharing with us his insight into working with Maya and using Simcenter tools during his time so far at IVI. So here we'll start with an introduction into IVI. I'll pass things over to Pierre-Luc, who will talk a little bit about its history and past and projects.
Thanks, Anthony. All right, so IVI is a short name for the Innovative Vehicle Institute. We're an applied research center in Quebec, just north of Montreal. We work with companies to help them stay ahead of the curve by creating cleaner and safer vehicles. We have experts developing electric vehicle prototype, autonomous vehicle, connected vehicles of any type. We do work a lot with trucks and buses, but we also touching a little bit about aircraft systems. We design and integrate innovative technologies applied to specialized vehicles. So we're mainly supporting those smaller volume, bigger vehicle, truck, buses. In the case we are discussing today, ground support equipment for aircraft as well. So some types of vehicle we worked on in the past. So we really are on and off the road. So we did the first prototype development for Lion Electric for their electric school bus. We also worked with a local company manufacturing the MadVac vehicles. Those are small vacuum cleaners that we help them power with battery. And then on a different scale and different type of environment, we also worked with a local company called Elmec to develop an autonomous tractor. This one is powered by 4 electric motors, full electric for weeding operations. So really putting together autonomous vehicles and electric vehicle technology in the same package.
Thank you, Pierre-Luc. So now that we've got a better understanding of IVI, what they do and why they do it, now let's take a minute and explore a bit of the background of collaboration between Maya HTT and IVI. So a little bit about Maya. Maya Heat Transfer Technologies, we help organizations with their digital transformation journey. Siemens has recognized us as their top North American partner in 2021. We're not just a consulting and systems integrator, we also develop software with over 30 modules authored for Siemens used by millions worldwide. Actually, 75% of Mayans are scientists and engineers with hands-on experience in nearly every industry. So whether an organization is looking to better design, simulate, manufacture, or optimize their operations, Maya HTT's combined engineering, software development, and AI expertise are uniquely positioned to help move from concept to completion. And IVI and Maya have worked together on multiple occasions to develop new projects and capabilities for the world of electrification and mobility. One such example was a collaboration in 2016, which involved IVI and Maya working together to improve co-simulation between thermal analysis tools and mechatronics for improved battery analysis. More recently, we've partnered again on a project to develop new technologies in electrification for aerospace. Now, a brief pause from current projects to look into how IVI is leveraging the Simcenter portfolio, particularly in their applications for the topics we have just introduced. So, Simcenter is a suite of tools that supports the electric vehicle design and innovation efforts in multiple ways, from its capabilities in modeling any type of vehicle, whether it's connected vehicles, autonomous, electrified vehicles from any perspective of subsystem, hybridization, e-powertrain, systems electrification, or from an integration perspective, as well as including the ability to perform engineering tasks on mobilities, such as customer to vehicle or infrastructure to vehicle type analyses. So Simcenter is built off of four main pillars for its engineering capabilities: the ability to model complexity, exploring different design possibilities and gaining insights, achieving speed and agility, and also maintaining integration by connecting all activities together. These four dimensions also correspond to the Simcenter portfolio to ensure state-of-the-art solutions for customers of any type. So all of these Simcenter solutions allow you to model the complexity all the way from material behavior to the performance of entire systems. This includes coverage for a broad range of physics, including structures, flow, electromagnetics, motion, thermal, and much more. Within Simcenter, we've developed now methods for reduced order modeling, workflow automation solutions, and AI-driven usability enhancements as just a few examples of how we enable individuals, teams, and entire organizations to go faster and improve their engineering. Using Simcenter delivers a number of benefits, including the ability to design and engineer better products, gain earlier insights and performance, and accelerate innovation, which ultimately helps achieve greater productivity. Now let's dive a little bit deeper into some of the solutions, and particularly ones that we'll be looking at today. Within Simcenter, we can focus here on system simulation. System simulation allows rapid creation of physics-based product models and all of their different aspects. Often by using predefined libraries, engineers can couple parametric descriptions of subsystems without requiring geometrical details, making it very suitable for early balancing of multiple design attributes during the concept phase. And during later stages, these models can then be gradually refined as more details become available. So here, system simulation's unique capacity to run in real time extends the application of the solution to the verification and validation process as well. Simcenter AIMSIM is the leading integrated scalable system simulation platform, allowing engineers to virtually assess and optimize the performance of mechatronic systems. This will boost overall systems engineering productivity from the early development cycle stages until final performance validation and controls calibration. Going forward, VSys is a suite of wiring and harness design software tools used to fulfill the requirements of companies where ease of use and value are as important as capability. This is optimized for rapid deployment and easy installation. VSys helps users with its powerful yet intuitive functionality. Design and harness tools can be used individually or deployed together, allowing wiring design data to flow seamlessly into the associated harness. Um, this reduces effort and minimizes the risk of errors. It allows for rapid, right, first-time, error-free electrical and harness design with numerous validation features, including simulation for continuity, voltage drop, and current direction calculations. Automated harness engineering for creation of production-ready drawings, bill of materials, costing, NC files, and manufacturing reports, as well as integration with 3D CAD systems, model in 3D and engineer the electrical detail with VSys. So now we'll hear again from Pierre-Luc about a recent project where they have made successful use of both of these tools. And now I'll pass things over to Pierre-Luc, who will talk a little bit more about that.
Yeah, thanks, Anthony. So yes, our project we're presenting today, the Rheinmetall EMSU. So it's a ground support equipment for lithium-ion battery-powered air start unit. So what it does is it provides air to an onboard air starter on the aircraft. It's the first of its kind on the planet, so really first to production to go electric. Those units are usually powered by diesel engines or are turbine-driven compressors. So this unit provides 250 pounds per minute of air at 56 psi. To achieve that, we require 375 kilowatt of power. And really what we wanted to do here is to leverage the available components from commercial vehicles and commercial and automotive vehicles on the market, really make use of what's available and proven in the field. And we wanted to showcase it today because it's a bit different from what we're used to with automotive commercial vehicles. But there's still a lot of similarities with these industries, especially when we're looking at tools for designing the unit. So maybe on the next slide, we have a bit more details on the specs. The machine, really higher voltage batteries at 700 volt DC with the same type of interface you would see on a commercial or on-road vehicle, a mobile permanent magnet motor and drive, automotive battery thermal management system that's separate from the rest of the electronics for a controlled temperature for long battery life. And then we use some proven pneumatic components from the ground support equipment industry. So it's really a crossover between commercial electric vehicles and ground support equipment. The unit has a similar footprint to a standard internal combustion engine unit. And really the biggest difference from the rest of the electric ground support equipment industry is we're running at much higher voltage, so 700 volts, like I said, compared to typically 80 or 1 and 10 volt DC. So it's a different ball game for the batteries and all the other components. We're really closer to what's available in the commercial vehicle market, and that's why we helped Rheinmetall design the unit. So if we go a bit deeper for the system integration, like I said, we do have the same challenge as an electric vehicle. So battery powered unit, really the only difference is the battery and the motor are not connected to the road. They are connected to the compressor, and the unit is mounted on the trailer. So but other than that, as for the engineering and system design, it's really the same challenge. So we want to improve efficiency, optimize for volume, weight, and price, especially in the batteries. And we need to integrate pretty much the same accessories. So thermal management, DC-DC converter, charger, pretty much the same as an electric bus. Only that the footprint is a lot smaller. So it's pretty much the only difference regarding the high voltage architecture. The only difference is we have a compressor on top of this electric architecture, and that's where AIMSIM really helped get it designed faster and get prototypes for testing out there is we could connect what we did for the batteries, the motor, for the system simulation, and connect it to an embedded CFD 1D solver to model everything pneumatic. So the compressor itself, and then the all the pipes, the valve. We use the AimSim capabilities to connect with Simulink to fine-tune the controller and simulation before putting the unit in the field, and trying to reduce typical issues with the compressor like surge, and try to have an adequate surge margin to have a safe system. Also, airspeed with that much air passing through the system is quite high, so we do have sonic speed in some parts of the system, meaning that we need to account for compressible flow. That's not something you would typically see or deal with in electric vehicles. But then again, the capabilities were already available in AimSim, so it made it really easy for our engineers to work with the system in a familiar environment, and making sure the system is not just a motor and battery powering a compressor, but a complete machine that's working well together. As for our system itself, we needed to build it and test it. And when you talk about electric vehicles, you talk about a lot of wires, obviously. So like I said, we have pretty much the same components as an electric vehicle, which means the harness is going to be of similar complexity. So using VSys, it really helped go from some simple schematics and then go through the more detailed electric design to finally have the harness design that could be projected to the assembly board, and enable the technicians to build the harness quite rapidly and make some changes in the field with the correct documentation if we see some kind of problem. So it really made all the debug phase of the project that much faster because the documentation was following the project we had, like the digital harness that was available that we could consult anytime and adjust for mistakes in assembly. And then, like I said, we do have, again, the same components as an EV, but the package is smaller. So we leverage the capabilities to connect VSys to our CAD system in Siemens NX, and try to figure out where the wire bundles would pass through the unit, if there's enough space for it, and making sure that it would fit correctly when we were building the prototype, making for cleaner integration really, and again, easier for the test engineers to work with, having a cleaner prototype when you do have some faults in the harness. It's easier to spot, faster to correct if need be, compared to having a wire spider in the unit. So in the end, we were able to support our partner to go into production sooner. So really having accurate models for both the electrical and mechanical system makes it really easier to transfer the information to Rheinmetall, and making sure they have all the required information to then build the unit in production. So that was a big help.
Great. Thank you very much, Pierre-Luc. And with that, it will take us now to the end of our presentation. Thanks very much for your input, and thanks to everybody for your time and attention during this presentation. We hope you found it informative. As usual, if there are any questions, comments, or anyone who would like to reach out to discuss anything further, which you saw here today, you can find our contact information here. You'll also find a QR code, which when scanned will give you access to one of our related white papers. And if you'd like to learn more, please feel free to visit our website, which is listed here. So thank you once again, and please enjoy the rest of the presentations.